So let's take a moment to talk about what banded iron formations, or BIFs, actually are. Because I'm not convinced your book actually does a great job explaining what these are and how they form. Now, I do want to mention, okay, and we're going to talk about this in the next chapter, in Chapter 9, that banded iron formations are no longer around. They disappear about 1.6 billion years ago. So from about, anywhere from about, let's say, 3.4 to 3.8 billion years ago to 1.6 billion years ago, we had these rocks called banded iron formations. Now, what a banded iron formation is it's a rock that has layers of unoxidized iron, it's going to be black, and then layers of oxidized iron, which are red. So what we see is this alternating layer of unoxidized, oxidized, unoxidized, right, oxidized. So this becomes important because first we have to understand, well, what would make iron oxidize? And this is something we haven't talked about yet, right? We have to have something in our atmosphere for organisms to live. You're breathing it right now. Hopefully you recognize that is oxygen. So oxygen is incredibly important for life. Plus it's going to be the one thing that's going to oxidize this iron. Now we know in Earth's early atmosphere there was no free oxygen. So we have to figure out, well, when does this time occur? When do we start to see the accumulation of oxygen in our atmosphere? So let's talk about how these banded iron formations occur. And in order to do so, we need to go way down to the bottom of the ocean floor. And at the bottom of the ocean floor, you might have seen these things called black smokers. They look like little volcanoes here. But what it's letting out is it's letting out a whole bunch. Now, it looks like smoke in the ocean, but it's not. It's letting out a whole bunch of chemicals. And most of these times, these chemicals are our four favorite ones: silica, oxygen, magnesium, and iron. It's letting them out into the water. So, the way these banded iron formations are occurring is we're going to have all of this iron floating around in the water. Because remember, erosion rates right now on our continent are really high. We're just starting to develop water. We've got a lot of oxygen, or we've got a lot of iron hanging out. So there's going to be times when these black smokers are maybe quiet, right? There's not a lot of plate tectonics going on underneath, right? We don't have rift valleys. Nothing's really going on. So in times when we don't see a lot of material coming out of these black smokers, all of this iron is just going to settle down to the bottom of the ocean floor. We're going to create a layer of unoxidized iron. Now, let's say our ocean floor here starts becoming active, and we start to see, right, all of this smoke come out here. So we're actually starting to add oxygen into the ocean. Well, what's going to happen when this oxygen in the ocean starts hitting these iron particles? Hopefully you decided they're going to start oxidizing and they're going to start falling down. But it's going to be like rust. That's what oxidizing is. It's just rust. So we're going to get this layer of rust. So really, banded iron formations are forming from the rusting of the oceans. So when we see these big belches of oxygen into the ocean, all of that material, right, starts falling down, right, and creating this. And then, of course, it's going to go quiet for a while because we used up all the oxygen. You're going to get an unoxidized layer. You get more oxygen, we get an oxidized layer. So these banded iron formations are actually really showing us that early on we're getting these pulses of oxygen, these belches of oxygen into the environment that's oxidizing this iron. However, it's not enough to completely oxidize everything, right? So we have these layers of unoxidized iron. We'll see that later on, and we're going to see where that 1.6 billion year range becomes important in Chapter 9.